Your app is growing, users are complaining that it's slow. Your single server is at 90% CPU and you need to fix it today, not next quarter, not after a big architectural rewrite today. So you do what every engineer does first. You make the machine bigger, more CPU, more RAM, a faster disk, and it works. The slowness goes away, the complaint stops, you ship nothing and it's fixed. That's a vertical scaling, and for a while it is genuinely the right call. But here's what nobody shows you. There is a ceiling, and the moment you hit it, you are not just slow again, you are stuck. In this video, we will cover what vertical scaling is and why it usually your best first move and exactly where it breaks down. Let's get into it. Vertical scaling means making your existing server more powerful. You take the machine you already have or swap it for a larger one and you give it more resources, more CPU cores, more RAM, faster storage, a bigger network card. Everything still lives on one machine. You are not adding more machines. You are upgrading the one you have. That is the entire idea. The reason it's called vertical scaling is visual. If you draw your architecture as a box on a whiteboard, vertical scaling makes the box taller. The box grows upward. You will see why that image matters when we get to horizontal scaling, where the boxes multiply outward instead. In cloud environment, vertical scaling is often just a few clicks. On AWS, you stop your EC2 instance, change the instance type, say from a T3 medium to an M5 4x large and restart. Your application code does not change, your database does not move, everything behaves identically, just faster. Stick this in your brain forever. Vertical scaling means one machine gets bigger. That's all. No new machines, no code changes, just more power on the same box. Think about a restaurant kitchen with a single chef. At first, the kitchen handles 20 covers a night. Your chef has a 2-burner stove, a small prep area, and one knife. It's tight, but it works. Then the restaurant gets popular, orders starts backing up, so you upgrade the kitchen, you install a 6-burner commercial stove. You bring in sharper knives, better pans, a bigger prep table, you hire more chef to handle the prep work while the head chef focuses on cooking. Each upgrade is fast and the kitchen immediately gets more capable. That is vertical scaling. Same kitchen, same address, just more firepower inside. And for a while, this is absolutely the right thing to do. Upgrading the kitchen is fast. You do not have to teach the waiters a new system. You do not have to restructure the menu. You fix the bottleneck directly and move on. But eventually, you hit the walls. Literally, the kitchen is fixed physical space. You cannot install a 10th stove. There is no room for a second head chef. The building electrical wiring cannot support more equipment. You have maxed out what that one kitchen can do. In your server, that wall is hardware. There is a biggest machine you can buy. At some point, no cloud provider has a larger instance type. You have hit the ceilings and buying a bigger box is no longer an option. That is the moment vertical scaling ends. There are 3 reasons vertical scaling is worth understanding well. Reason 1. It is almost always the right first move. When your app first starts slowing down under load, the fastest, cheapest fix is usually to resize the server. No code changes, no new infrastructure, no risk of introducing distributed system bugs. You fix the problem in an hour and get back to building features. For early stage products, that speed matters a lot. Reason 2. Interviewer test your judgment on this. In system design interviews, knowing when to scale up versus when to scale out is exactly the kind of trade-off question they want to hear you reason through. Being able to say vertical scaling first for these reasons and then I will switch to horizontal when I hit this specific constraint is a strong answer. Reason 3. Some components resist horizontal scaling. Relational databases, in particular, are hard to scale horizontally without significant re-architecture. Vertical scaling buys you time to get that work done properly without rushing it under pressure. Here's where we are going. Look at the upgrade ladder. The left box is your starting server, a small instance, say 4 virtual CPU cores and 8 GB of RAM. with 100 gigabytes of SSD storage. This handles your app fine at low traffic. Traffic grows, the CPU start hitting its limit. You resize to the middle box, 16 cores, 64 gigabytes of RAM, 500 gigabytes of disk, same application code, same database, just running on bigger machine. Your response times drop back to normal. Traffic keeps growing. You upgrade again to the right box, 96 cores, 384 gigabytes of RAM, 4 terabytes of NVMe storage. This is a serious machine. On AWS, something like an X2 IEDN instance. It costs a lot, but it works. Now look at the ceiling line across the top of the diagram. That line is real. Cloud providers offers a finite range of instance type. There is a largest machine beyond that line. Vertical scaling is over. You have no more boxes to move to the right. And there is a second problem that the diagram does not say out loud. Even at the large box, all three boxes, you still have one machine, one set of hardware, one network card, one power supply, one point of failure. If that machine goes down, your application goes down. Every user all at once. Vertical scaling makes your server more powerful, but it does not make it more resilient. Now look at the comparison diagram. On the left, vertical scaling, one box growing upward, eventually hitting the ceiling. On the right, horizontal scaling, multiple equal boxes sitting side by side with a load balancer in front. Horizontal scaling removes the ceilings and adds redundancy, but it also adds complexity. Your application code has to be designed for it. The insight here is that vertical and horizontal are not enemies. Vertical scaling is the first move. Horizontal scaling is what you plan for next. I want to be honest with you about something most courses won't tell you. The good news, vertical scaling is fast, simple, and zero risk from a code perspective. No distributed system to manage, no load balancer to configure, no session state to worry about. You stop the instance, pick a larger size, restart, done. If you are an early stage team and the bottleneck is just a raw compute, this buys you months, sometimes years of headroom without touching your architecture. The bad news, there are two hard limits. First, there is a physical ceiling. The largest machine on any cloud provider is still finite. Second, and this is the one that bites people, you still have a single point of failure. One machine means one crash brings everything down. When not to use it? When you need a high availability with no single point of failure, or when your traffic spikes are unpredictable and you need to scale in minutes, not the time it takes to stop and restart a large instance. Now you acquire good knowledge to answer this interview question. Question 1. What is vertical scaling and how does it differ from horizontal scaling? Vertical scaling means making your existing server bigger, more CPU, more RAM, more disk without adding new machines. Horizontal scaling means adding more machines and distributing traffic between them. Vertical is simpler to implement but has a hard ceiling and no redundancy. Horizontal removes the ceiling but requires your application to be designed for it. Question 2. What are the limitations of vertical scaling? Two main ones. First, there is a maximum machine size. At some point, no provider offers a larger instance. Second, you are still running on a single machine, so any failure take down your entire application. Vertical scaling adds power but not resilience. Question 3. When would you choose vertical scaling or horizontal scaling in a system design? Early on, when the bottleneck is pure compute and you want a fast fix without re-architecting. Also useful for stateful component like relational databases, where horizontal scaling requires significant work, sharding, replication, coordination that you may not be ready for. Vertical scaling buys you time to do that work properly. Know those three answers and you will handle the scaling trade-off question in any interview. Before you go, take 30 seconds to log this in. Takeaway 1. Vertical scaling means making your existing machine bigger. More CPU, more RAM, more disk with no code changes, no new machines. Takeaway 2. It is almost always the right first move. Fast, simple, zero risk from an architecture perspective. Use it to buy time. Takeaway 3. It has a two hard limits. There is a maximum machine size you cannot exceed and you still have a single point of failure. At that point, you have to go horizontal. Vertical scaling buys you time It does not buy you infinity. Trust me. In the next video, we are covering horizontal scaling, adding more machine instead of making one machine bigger. That's where the real complexity of distributed system begins. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.